Data comes in a wide variety of shapes and formats. Hadley Wickham wrote a paper about tidy data in 2014 that formalizes the way we can describe the shape of our data and gives us a goal when formatting our data. He states in his paper that tidy data provide a standard way to organize data values within a data set. There are many reasons why a standard approach to data cleaning is good, and a tidy data paper is worth the read to better understand how the shape of data fits into the various components of data analysis. Here's an imaginary experiment adapted from the tidy data paper. Each individual has a treatment value for each of the two possible treatments. Here's another representation of the same data. The information conveyed in the tables are exactly the same. This is why we need a more formal and standard way of describing the shape of our data. There are three principles of tidy data. The first is that columns represent separate variables. The second is that rows represent individual observations. And the last is that each type of observational unit forms a table. We won't cover the last point in this chapter. In our treatment data, the columns do not represent separate variables. They represent different values, A and B, for the variable treatment. We can reorganize the table of values into this new tidy format. Each observation will contain the name, the type of treatment, and its result. At first, the format of our data may be strange, and some may argue that the information is harder to ingest because it's not as easy to compare treatment differences for a particular person. But that's partially the point. There are data formats that are better for reporting and data formats that are better for analysis. If we aim to make our data tidy during the data cleaning process, we can fix common data problems along the way and be able to quickly transform data into different shapes as needed. Wickham defines the data problem we are trying to fix as columns containing values instead of variables. We fix this data problem by using the pandas function melt. Here, I've saved the treatment data into a data frame named df. To melt our data, we first specify the data frame we want to use and which column or columns we want to hold constant. Here, we want the column that stores the names of people to be fixed, so we pass that into the ID_vars parameter. The result is a melted data frame where we have a column called variable that holds the treatments and a column called value that holds the treatment values for a given individual. Melt has a parameter called value_vars for you to specify which columns you want to melt. If you don't specify this parameter like we just did, Melt will use all the columns not specified in the ID_vars parameter. The default variable column name is not always what we want. We can rename the new melted columns with the var name and value name parameters so we have more meaningful column names. The opposite process of melting is called pivot. In melting, we turn columns into rows. Now, in pivoting, we will take each unique value of a variable and turn them into separate columns. One reason we may want to pivot our data is to reshape our data from an analysis-friendly shape into a report-friendly shape, or when our dataset violates a tidy data principle, where rows do not contain observations. Specifically, when multiple variables are stored in the same column. Here's an example from Hadley Wickham's tidy data paper. We have a dataset of min and max temperatures for a particular date. You can see how the min and max temperatures are reported in separate rows, causing the dates to be duplicated. We want a dataset that gives us a date for each row. That is, a date is an individual observation, and for each date, we have the min and max temperatures. Here is the tidy dataset after the element column is pivoted. You can now see how the new table follows the mantra of tidy data. Every row is an observation, and every column is a variable. To pivot our data, we call the pivot method on a data frame. We pass in the index to denote which column or columns we want to fix during the pivot. Next, we pass the columns keyword argument for the column we want to pivot into new columns. Finally, the values to be used to fill in the new columns created from the pivot. You may find that the pivot method will not always work. Here is our original weather dataset with another weather dataset I've saved as weather 2. The second dataset has a duplicate tmin for February 2nd, 2010 date value. If we simply use pivot on the second dataset, you'll get a value error, saying that there will be duplicate entries and cannot be pivoted. That is, there are 2 tmin values for February 10th, 2010. Python has no idea how you want to reconcile the duplicate values. This is when we use the pivot table method instead of pivot. The pivot table method allows us to provide a parameter that will tell Python how to aggregate these duplicate values. I'll show you how to take the average of the tmin values for February 10. Pivot table is very similar to pivot. We call the method on a data frame of interest. Pass in the values keyword argument for the values that will be used to fill our columns after our data is pivoted. The index represents which columns we want to fix during the pivot and the column we want to pivot. Finally, we need to address what happens when there are multiple entries for a given pivoted variable. We use the aggfunc for aggregation function parameter to tell Python how to handle multiple values. Here I'm using the mean function from the NumPy library to take the average of the values. Now it's your turn to tidy data using the pivot method.